This tutorial will demonstrate how to perform two basic forms of generalization. Again, we'll be using XL Data Analyst, and generalizations which we discussed in class are confidence intervals and hypothesis test. Confidence intervals actually represents or calculates a range of population parameters for an average or a proportion. And in statistics, we usually are interested in the population, what happens in the population on high level. We rarely care about the properties of the sample. The sample is used only as evidence, as initial evidence to infer, to generalize from the sample what happens on population level. So, for example, in a sample we might calculate an average, but this is not the population average. It's only a sample average. To know what is the population average, we calculate a confidence interval, which, as the name implies, is a range of values where we believe that the true population mean or proportion is within the calculated range. So confidence interval is the first most basic form of generalization. Before deciding how to calculate to use averages or percents, it's very important. It's really important to determine the nature of the variable, if it is metric or categorical. Actually, this applies for every statistical operation. So determining the nature of the variable, if it is metric or categorical, is imperative. So let's say I would like to calculate the number I would like to know how many people live in a household on population level, or for the whole American public. In this data set we have only 1000 observations, and I would like to infer based on these 1000 observations the number of people in household for the whole American population. Number of people is a metric variable, so I need to calculate confidence interval for average. So click it and click number of people in household, and see that number of people in household for the particular sample consisting of 1000 observation is 2.2. However, on population level, I am 95% confident that the number of people living in household ranges between 2.1 and 2.3 people on population level. So if in an essence, this is a generalization for the American public based on the evidence provided by the sample. I can calculate another average, and let me calculate a confidence interval for the variable called probability of buying a standard size electric auto within 3 years. This is a metric variable, and the respondents entered a number between 0 and 100, indicating the probability to buy this particular car. So let's calculate the confidence interval for this probability, so that we know how the American public feels about purchasing this type of car. So we go to generalize confidence intervals, average, and we search for this particular probability, which is this variable here. Probability of buying a standard size electric auto within 3 years. Click OK. And here is the name of the variable. And in the particular sample, there are 1000 observations, and for the sample, the average is 34.6. However, we want to know how the American public feels about it, not how the people in the sample feel about it. So we can say we are 95% confident that on population level, or the American people, the probability of buying a standard size electric auto within 3 years ranges between 33.3% and 36%. So this is how we apply confidence intervals. Confidence intervals also can be applied for categorical variables. For to calculate the proportions for their individual levels. For example, marital status. Marital status is a categorical variables with two categories corresponding to unmarried and married people. Let's say I would like to know what's the proportions or what's the range of the unmarried and married people in the whole American population, not just in the particular sample. So I need to calculate confidence intervals for these two categories. To do so, go to XL Data Analyst, generalize confidence intervals, but this time we select percent because this is a categorical variable. Click it. Then marital status. And I can select one, deselect the other, or select both of them. I would want to calculate the confidence intervals for both of these categories. Click OK. And we see that these are the unmarried and married people within our sample, which corresponds to these two numbers, these two proportions within the sample. But what can we say about unmarried and married people on population level for the whole American public? Well, we can say that we are 95% confident that the proportion of unmarried people in the American public is between 45.6 and 51.8%, and we are 95% confident that the proportion of married people in the American public ranges between 48.2% and 54.4%. So that's it. Okay, quickly one more. Just another. Let's calculate the proportion of people with college degree in the American public. It's again a categorical variable, so we need to calculate confidence intervals. A confidence interval for percentage. I select level of education. People with college degree. I deselect the other one. Now I'm gonna calculate the confidence interval only for this category. And here is the result. I can say that I'm 95% confident that in the American public, people with college degree range between 19.6% and 24.8%. So this is how we calculate confidence intervals for averages, for metric and categorical variables.